Hello guys, welcome to the channel H2O, the A to Z of chemistry. To make the study of inorganic chemistry very easy for you people, today I'm going to be sharing with you some quick easy tricks from the topic Group 15 Elements P Block Class 12th Chemistry, which is going to be very important for you. And from the Group 15 Elements, the topic that we have chosen today is going to be the preparatory reactions of nitrogen and ammonia, which are going to be very important for your JEE and NEET examination. So all the reactions for nitrogen and ammonia, how we prepare them, I am going to be giving you a very easy trick which is going to really help you excel in your examination. So let us begin the learning. I hope you are going to enjoy this lecture with me. So let us start this lecture by looking at the preparatory reactions of dinitrogen which are given in the NCERT textbook. Reaction number 1 that is given is by heating a mixture of NH4Cl and NaNO2, ammonium chloride and sodium nitrite. The product that is going to be formed is going to be nitrogen, water and NaCl. The next reaction which is given in the NCERT textbook is by heating ammonium dichromate NH4 whole twice Cr2O7, and the product that is going to be formed is going to be N2 water and Cr2O3, that is chromic oxide. The next we have is by the thermal decomposition of barium azide, that is BaN3 twice, and the product that is going to be formed is going to be barium and nitrogen, and this is the way in which purest form of nitrogen this is prepared. Okay, so these are the three reactions. Well, they are very easy reactions, not difficult to remember, but well, the problem is that after some time you are going to forget them, right? So we are going to today learn them in such a way that you do not forget these reactions. Plus there are going to be certain more reactions which I will be adding up over here. All of them you will not be forgetting, and yes, there is going to be reactions for the preparation of ammonia also that I will be showing you. Okay, but before that I just want you to look at this question which is from JEE Mains 2018. The question says that the compound that does not produce nitrogen gas by the thermal decomposition is ammonium dichromate. So you can see over here that we have this reaction in the NCERT textbook. Ammonium sulfate, well, it is not given, but there are so many things which are even asked in the examination and we have not studied those reactions. So there comes a thought, well, is it going to give nitrogen or not? Then we have ammonium nitrite. We did not study this reaction. We studied the reaction of ammonium chloride and sodium nitrite, but we did not study the thermal decomposition of ammonium nitrite. Does this produce nitrogen or not? No idea. Again, barium azide, yes, you have studied. Okay, so these are the two reactions which you must have studied, but then these two you are not very sure of whether they will be producing N2 or not, and then you get stuck up whether to mark the answer or not, which one to mark or not. So today in this lecture, I am going to give you a trick to remember very easily all these reactions. Along with that, the preparatory reactions of ammonia, and these are going to be in such a way that you are not going to be mugging up the reactions. You are going to understand them in a very interesting way. Okay, so are you ready? Good. So the trick by which you can remember the preparatory reactions of nitrogen and ammonia is going to be learning the thermal decomposition of ammonium salts. So we have ammonium salts. We are going to heat those salts. What is the product that is going to be formed? We will be learning that with the help of some tricks, and that will be giving you the preparatory reactions of both nitrogen as well as ammonia. Okay. So here I want you to look at a few examples. We have ammonium carbonate. On heating, this gives us ammonia, water and carbon dioxide. What is going to be the product form? Well, I'm going to give you a trick to remember all these products. Do not worry, but just look at these examples first of all. The next reaction, ammonium bicarbonate. On heating, this gives us again ammonia, water and carbon dioxide. Another reaction, ammonium hydroxide. On heating, this gives us ammonia and water. So from these three examples, what you can understand is that when we have an ammonium salt, we are heating it. What is being produced? Well, ammonia is being produced in all these reactions. But does that mean that all ammonium salts form ammonia on heating? Well, you all know the answer because you have just now seen one reaction in which nitrogen was produced, and that was ammonium dichromate. When we heat ammonium dichromate, the product that is formed is N2, water, and Cr2O3. So here ammonia is not being produced and nitrogen is being produced. Let us look at one more reaction. We have ammonium nitrate. When we heat this, the product that is formed is N2O and water, right? So now we are heating these different ammonium salts and we are getting different gases. Somewhere we are getting ammonia, somewhere we are getting N2, and one way we are also getting N2O. So if you understand what is going to be the product form from which ammonium salt, well, the work is going to be half done. And then it is going to be just remembering what are the other side products that are going to be produced along with the ammonia gas or nitrogen gas. Okay, so now I'm going to tell you how you're going to remember these reactions. So what we will be doing to understand what is going to be the product form is looking back at these reactions in a greater detail. Let us look at one example, that was ammonium carbonate on heating giving us ammonia, water and carbon dioxide. So here please do write down what is the oxidation number of nitrogen in ammonium carbonate as well as in ammonia. Well, it is going to be -3 in both the cases. In the ammonium ion also and ammonia, both nitrogen is in -3 oxidation state. So what this means is in this reaction there has been no change in the oxidation state of nitrogen. But if you look at this one example, we have ammonium dichromate on heating giving us nitrogen, water and Cr2O3. Here you will be seeing that the oxidation number of nitrogen in ammonium dichromate is -3, whereas in nitrogen it is 0. So here there is a change in oxidation state from -3 to 0. An increase in oxidation number means there is oxidation of nitrogen taking place. Now what is causing this change in the oxidation state of nitrogen? Well, there is no other thing apart from this one reactant that we have. So it is change in the oxidation state of the cation taking place, and that is going to be by the anion. For example, in the Cr2O72 minus, the dichromate ion, this is causing the change in the oxidation state of nitrogen from ammonium ion to nitrogen, and the carbonate ion is not causing the oxidation of nitrogen from ammonium ion to NH3. So there is no change in oxidation. So what this means is that if we understand these anions in a better detail, well, we are going to very easily learn the products that are going to be formed. Let me explain you how. So what we will be doing is a trick to remember the product is going to be the anion. We are going to classify the anions into two types. One are going to be the oxidizing anions, which are going to cause a change in the oxidation state of nitrogen, and one are going to be the non-oxidizing anions or weak oxidizing anions, which do not cause a change in the oxidation number of nitrogen. For example, we have the oxidizing anions 2BnO2 minus, NO3 minus, MnO4 minus, Cr2O72 minus, ClO4 minus, IO3 minus. So these are the 6 oxidizing anions that you have to learn for these ammonium salts. Apart from these, all the anions that we will be having, for example, the carbonate ion, the bicarbonate ion, OH negatives, SO4 2 negative, PO4 3 negative, iodide ion, chloride ion, bromide ion, the halides that we will be having. So all of these, they are going to be categorized into the non-oxidizing anions. When these anions are going to be present, there is not going to be a change in oxidation number of nitrogen, right? So what will happen is when we have an ammonium salt, of the ammonium ions with any of these oxidizing anions, the product, one of the products is going to be definitely nitrogen. there is going to be release of nitrogen gas with the exception of the nitrate ion, which is not going to release nitrogen, but it will be releasing N2O. All right. And then the non-oxidizing anions, when they will be present in the salt with the ammonium ions, the product that we will be getting is ammonia gas. Right. So I think it is going to be very easy if you just remember these 6 anions. These 6 anions, the product is going to be N2, and even the nitrate ion, if you just remember it is going to be N2, the way I'm going to teach you to write down the products, you will ultimately get this N2O also. All right. So these are the oxidizing anions and these are the non-oxidizing anions. So let us see now how the products are going to be formed. So now let us learn first of all the thermal decomposition of ammonium salts containing oxidizing anions. All right. So how are we going to learn the product which is going to be formed by the thermal decomposition of, for example, ammonium dichromate? Right. So I do not want you to mug up the products that are going to be formed. I am making your study easy by giving you an understanding how to write the products without mugging up the reaction. So first of all, what you have to do is identify which is the anion that is present. So Cr2O72 negative, this is an oxidizing anion, and when it is an oxidizing anion, it is going to release N2. So this is one thing that you have to remember, the 6 oxidizing anions. So Cr2O72 negative, the dichromate ion, this is an oxidizing anion, and when it is an oxidizing anion, it is going to release nitrogen gas. This is the only thing that you have to remember for writing down the products of this reaction. Okay. Now, first of all, you have got this N2. Now, what are the remaining products that are going to be formed? So, if you see N2, this means from ammonium dichromate, we had 2 nitrogen atoms, which we have taken out. From the remaining, what you have to do is you have to see how many hydrogens they are present. So, this is going to be H4 into 2, that means 8 hydrogen atoms. 8 hydrogen atoms can give us how many water molecules? Well, it is going to be 8 divided by 2. That will be 4, because in each water molecule there are going to be 2 hydrogens present. So count the number of hydrogen, divide that by 2 and convert these into that many number of water molecules. So ammonium dichromate, the second product that will be formed, are going to be 4 water molecules. All right. So now 4 water molecules means that 4 oxygen also have been used from ammonium dichromate. So nitrogen gone, hydrogen gone. What is remaining behind? Just count that. So what is it? It is going to be 2 chromium atoms that is going to be left, and there will be 3 oxygen atoms that will be left. Simply just write them together and you will be getting the product Cr2O3. So what is going to be the final product of this reaction? Ammonium dichromate on heating is going to give us nitrogen gas, 4 water molecules plus Cr2O3. Isn't it easy now? Yes, it is. Let us see one more example. The next example is NH4NO2 ammonium nitrite. So what are going to be the products formed? Let us see that. First of all, we see what is the anion. This is NO2 negative. So this is also an oxidizing anion. And when we have an oxidizing anion, what is going to be one of the products? It is going to be nitrogen gas. So you have written nitrogen. So next step, what is it going to be? 2 nitrogen gone. You have to see how many hydrogen atoms there are present. So there are 4 hydrogen, means there are going to be 2 water molecules that will be formed. And after the formation of 2 water molecules, all the atoms, they are finished in this. So this means this is the final product of this reaction. Ammonium nitrite on heating will give us N2O, and along with that 2 water molecules. Let us look at one more example. I think this should be very easy. So again, NO3 negative is the anion. This is an oxidizing anion. So one of the products, we write it as nitrogen, and then we are going to count out how many what hydrogens they are present. So hydrogens, they are 4 in number, so we will be getting 2 water. After that, you will be saying what is left. What is left is going to be just one oxygen atom. So that one oxygen atom, just put it with again N2. So this will be giving us N2O. So this was the only exception from the oxidizing anions where nitrogen gas was not released. It was N2O that is getting released. So this is also very easy to remember. No problem in learning it. Great. So now let us see one more example, NH4ClO4. What are going to be the products formed? And I would like you to pause the video here and first of all try writing down the products yourself. So if you've done that, let us see how we are going to do it. First of all, ClO4 negative is the anion. This is an oxidizing anion. So there is going to be release of nitrogen, but nitrogen is N2 and here we have just one atom of nitrogen. So simply multiply this by 2. So we will be having 2 molecules of NH4ClO4. All right, so we evolve nitrogen from here. Now next step is going to be seeing how many hydrogens present. So it is going to be 2 into 4, 8 hydrogens. That means 4 water molecules, and remaining what is going to be left is 2 chlorines and 4 oxygens. Now what is going to be the product that is going to be formed? This is different from what you have already learned. What we have learned was we are just going to write this together. And writing this together would mean Cl2O4. But that is not what is the product form. So please do remember a small little trick over here. If the leftover atoms, they have a metal, write all the atoms left together to form an ionic compound as we did for Cr2O3. But when these remaining atoms, they do not have a metal, all of them, they are non-metals, then you are going to write them down separately. So what this means is 2 chlorine atoms are going to give us 1 chlorine molecule and 4 oxygen atoms will be giving us 2 oxygen molecules, right? So the total product is going to be NH4Cl4 giving us nitrogen, water, chlorine and oxygen. So now I think all the oxidizing anions with the ammonium cations, the salt formed, and you have to heat them, the product that are going to be formed should be very clear. You do not have to mug them up, but you know the product any which is going to be coming in your examination. So if I ask you NH4IO3, the product that will be formed is N2 plus water plus I2 plus oxygen. So next let us learn the thermal decomposition of ammonium salts containing weak or non-oxidizing anions. All the anions apart from the 6 we have learned as the oxidizing anions. For example, we have to heat ammonium carbonate. What is the product that will be formed? So again, we identify what type of anion the carbonate ion is. So carbonate ion, this is non-oxidizing in nature. So definitely what is going to be the product that will be formed? It will be ammonia gas that is going to be released. So oxidizing, it is nitrogen, and non-oxidizing, it is going to be ammonia. So one product we know for sure, the heating of ammonium carbonate, this is going to give us ammonia, but along with that carbon dioxide and water are also going to be evolved. So how are we going to remember these products now? Do we have to mug them up? No, not at all. Then what are we going to do? Well, we are going to follow a very simple trick. And the trick is replace the ammonium ions with H positive to form the corresponding acid. What this means is ammonium carbonate on heating, this is going to give us 2 ammonia, and along with that it is going to give us H2CO3. Okay, so we had 2 nitrogens, corresponding to that we have 2 ammonia, and then what we did was simply replace the ammonium ions by H positive. So that became H2CO3. So this is now what you have, and then what you are going to do is this acid, we are going to dehydrate it, remove water molecules from that corresponding to the number of hydrogens. So when you are going to heat H2CO3 Two hydrogen means one water molecule gone out, and what will be remaining behind is carbon dioxide. So this is going to be the products that will be formed on the thermal decomposition of ammonium carbonate. Ammonia, carbon dioxide and water. So let us look at a few more examples now. So we have ammonium sulfate. In ammonium sulfate, the anion sulfate is going to be non-oxidizing. So the gas that will be released, we know, is going to be ammonia. Right? So we have two nitrogen over here, make two ammonia molecules, replace the ammonium ion by hydrogen ion. So what you will be getting is H2SO4. Now you have to remove water from H2SO4. When you're going to remove water from H2SO4, what you will be left behind is SO3. So this is going to be the product from thermal decomposition of ammonium sulfate is going to give us ammonia, water and sulfur trioxide. Okay, the next we have is ammonium phosphate. So ammonium phosphate on heating, again phosphate ion non-oxidizing, so ammonia gas will be released. We have three nitrogen, so we make three ammonia over here. Replace ammonium ion by hydrogen ion, so what you will be getting is H3PO4 phosphoric acid. Again you have to thermally heat it, so what you will be getting is removal of water, dehydration of the oxo acid. So when you're going to remove it, what you will be getting is HPO3. But here again, you can see that there is hydrogen and oxygen present. So you can still further heat it and remove all the water from it. But for removal of water, what you're going to require is two hydrogens. So you will have to multiply this by HPO3. Okay, so you have to multiply the whole reaction obviously by 2 for the net overall reaction, but that I hope you all can do it when you are going to just write down the overall reactions. Okay, so what you will be getting is H2, P2 and O6, and from this now you can easily remove water molecule. So what will be gone is hydrogen, this is gone, and from here oxygen gone, so this will be P2O5 that will be left behind. So on thermal decomposition further, what you are going to be getting is water and P2O5. So the net overall product that will be formed is going to be ammonia, water and P2O5 from the thermal decomposition of ammonium phosphate. Okay, let us see one more example. We have ammonium hydroxide now. So ammonium hydroxide, again OH ion is non-oxidizing. So what is going to come out is ammonia. We have one nitrogen, so one ammonia molecule, and after that you are going to just replace ammonium ion by hydrogen. So what you will be getting behind is water. Okay, so the products formed is ammonia and water. So simple to remember. Next we have is ammonium chloride. Again, what is going to be coming out is ammonia. What will be replacing it by hydrogen? What you will be getting is HCl. Easy enough. Now I do not think it is going to be very difficult for you to remember these reactions. You just have to write them once and they are going to stick into your mind. What you have to just simply remember is which is non-oxidizing anion and which is oxidizing anion. And again there you have to just remember that we have the list of oxidizing anions. That is the all we have for oxidizing anions. Rest everything is going to be non-oxidizing and that is going to be giving us ammonia. Okay. So now let us look back at the preparatory reactions of dinitrogen. The first reaction was by heating a mixture of ammonium chloride and NaNO2. Okay, so the product that is formed is N2, water and NaCl. So how will you remember it? Let me show you how. First of all, we have ammonium chloride and NaNO2. So this is going to be a double displacement reaction. Just switching off the anions on both sides. Okay, so you will be having ammonium nitrite that will be formed and NaCl. Just interchange of the anions for the cations. Okay, so ammonium nitrite and NaCl, and now you have already learned the thermal decomposition of ammonium nitrite, right? So ammonium nitrite on thermal decomposition is going to give you what? This is an oxidizing anion. When it is an oxidizing anion, so what we are going to do is we are going to remove nitrogen, N2 gone. So 2 nitrogen gone, and then we have to just check out how many hydrogen. So how many hydrogen? 2 hydrogen. So we will be making up, sorry, 4 hydrogen. We will be making up 2 water molecules. Okay, so what is going to be the product formed? N2, water and NaCl. Okay, now let us look at the next one by heating ammonium dichromate. So ammonium dichromate we've already seen over here also. I hope I do not have to elaborate this reaction because you've already seen it. First of all, dichromate ion is going to be oxidizing in nature. So N2 is going to be coming out. Then you are going to count out how many hydrogens, 8 hydrogens, so 4 water molecules. And what is left behind is Cr2O3 after taking out these, so that are going to be the products that will be formed. Now one reaction which you have to remember is going to be the thermal decomposition of barium or sodium azide, by which very pure nitrogen is going to be formed. Okay, so this is important and this is very easy to remember also, that we have BaN32 to be called as barium azide. So the azide ion is N3 with -1 charge. Okay, so we have barium azide and we have sodium azide. They will be giving the respective metal, and along with that nitrogen will be evolved. Now one more thing which you have to remember as far as the preparation of dinitrogen is concerned, where there is no reaction involved, but it is important, and that is that nitrogen can be produced commercially by the liquefaction and fractional distillation of air. So you know that air is composed of 78% nitrogen. So we can get nitrogen from air also. First of all, we liquefy the air. When we do the fractional distillation, liquid nitrogen, this has a lower boiling point, that is 77.2 Kelvin. So this will distill out first and leaving behind liquid oxygen, which has a boiling point of 90 Kelvin. So now we move on to the preparatory reactions of ammonia. So first of all, what we have is the decay of nitrogenous organic matter, for example, urea in the soil. And here you just have to remember, first of all, what is urea. Okay, so that much you have to remember, that it is NH2CO NH2, and when it is going to be present in the soil, so there will be some water also present. So urea plus water, it is just going to add up to give us ammonium carbonate. Okay, so this is one step that you will have to remember, that this is forming ammonium carbonate. And then you know, ammonium carbonate on thermal decomposition, what does this give? Carbonate ion. So carbonate ion, non-oxidizing, it will be giving us what? It will be giving us ammonia. So we have 2 nitrogen, so 2 ammonia. Replace ammonia by hydrogen, so what you will be getting is H2CO3. H2CO3 will be giving us water and carbon dioxide. So the net product that will be formed is 2 ammonia, water and carbon dioxide. Let us look at the next one. We have the decomposition of ammonium salts when treated with NaOH or calcium hydroxide. Okay, so reaction number 1, which is given in your NCERT textbook, is ammonium sulfate and NaOH. Again, do the double displacement of this. Okay, so when you're going to do that, what you will be getting is ammonium hydroxide and Na2SO4. Again, ammonium hydroxide, you know, hydroxide ion, this is non-oxidizing. So you will be getting ammonia. Along with that, what you will be getting is water, and you can just balance out the reaction and find out the total product that will be formed is going to be ammonia, water and Na2SO4. Easy enough now? Good. So the next we have is ammonium chloride, and along with that calcium hydroxide. So again, what are you going to do? First of all, the double displacement reaction of it. So just interchange the anions, ammonium hydroxide, calcium chloride, ammonium hydroxide. Again, you know the product will be formed is ammonia and water. Just add up all of this. What you will be getting is ammonia, water, calcium chloride. Okay, so now I think these reactions should be very, very easy for you people. Any sort of reactions, if they are given, you can write them very well. Okay. The next, now one more thing which is going to be important for you people, which we have not discussed over here, but it is one of the important reactions for the preparation of ammonia, and this is a reaction which you have learned many a times, and a very easy one also, that is the industrial preparation of ammonia by the Haber-Bosch process, which is an endothermic reversible reaction involving a decrease in volume. Okay, so we have the reaction to be N2 plus 3H2 giving us 2 ammonia. This occurs in the presence of iron and molybdenum. Iron as the catalyst and molybdenum as the promoter, and this is a very, very important reaction. You have to remember the Haber's process. Okay, so these are the reactions that we have for nitrogen and ammonia. So that would be all for this lecture. I hope you enjoyed your learning with me. We are going to be coming up with more tricks, more concepts, more questions for you people to excel in your JEE and NEET examination. Along with that, we are putting up detailed courses also for you people. So please do check out all our playlists, and whatever you are lacking in knowledge, please do learn up the concepts very well. So please do subscribe, like and share if you are liking these lectures. And one more important thing, that if you have any doubts, you can post your doubts in the comment section related anything to chemistry from JEE and NEET examination. You can also mail your doubts to us at h2ochemistry@gmail.com. We will be glad to help you people. So see you again. Have a nice day. God bless you.